Hi, so my name is Ryan Meitinger and I'm working with the SpeedMaker study. I'm doing electromyography, and what electromyography is just the measurement of the activity in the muscle while you're doing some sort of activity. Anytime you're moving, your muscles will be active because they have to move you. So how we measure that is we use these electrodes right here to pick up that activity within the muscle through the skin. Those electrodes send that then wirelessly to the computer here, where we pick that up and we see this nice squiggly lined activity. So what we see here is we see these little spikes here. This is every time the muscle is active and moving the leg. This is the gluteus maximus, so that helps with extending the hip. And this one's active every time you're pushing forward, or every time even when you bring your leg up, it activates a little bit with that as well too. We also measured the rectus femoris and the biceps femoris as well, and so that's essentially the whole thigh is what we were measuring, and then the glute as well. Alrighty, so in the SpeedMaker study we used these reflective markers here to check knee and hip angles, and then other than that we also did electromyography where we used these clips here. Flex bottle. And we clip them on there, and that picks up the electrical activity in the muscle. So this is a device we're using for the SpeedMaker study. As you can see, it says SpeedMaker on it. And it has a strap already on there, and I'll strap one more on here. And what they will do is they will run and jump and such with this while they're training, and then hopefully it improves their abilities. Go.
Hi, I'm Mindy Clark. I'm a first-year master's student here at Northern Michigan University, and for the SpeedMaker study I'm looking at the kinematics of the hip angle as track and lacrosse athletes wear a SpeedMaker resistance device, which is supposed to increase the strength and power in the hip extensors, which should make for a more forceful push-off as we look at the muscles in the hip angle. So for the kinematics we look using the motion analysis system, which looks at cameras. We place reflective markers on a person's shoulder, their hip, their knee, and then their mid-shank, so that we can focus on the hip and the knee angles. If we look over here, this is our shoulder marker, this is our hip, our knee, and our mid-shank. So as we go through, we can look at the difference in the hip and the knee angles as they go through a stride when they sprint. Right, when we use the motion analysis system, we have 7 infrared cameras that pick up the reflective markers that we place on the subjects, and those track the different movements so that we can look at the angles. Here you can see one of our track athletes sprinting 50 meters. On her left side you can see the reflective markers on her shoulder, hip, knee, and her mid-shank.
Hi, my name is Dan Zuba, and I'm here at Northern Michigan University. We're working on the SpeedMaker study, and I'm looking at vertical jump forces and vertical jump height. And to do this, we're using the force plate, which can measure the amount of force that goes into the ground. We have Stephanie over here on her force plate. She's going to perform a jump for us. All right, 3, 2, 1, jump! There you go, Stephanie. All right, now on the screen here we have her results. This right here is when she's just standing on the platform. This here is when she begins her counter movement and she's putting force into the plate. This down here where there's nothing is when she's in the air, and this is when she lands. What I'm looking at specifically is how quickly she can put force into the platform and how long she will stay in the air. All right, that's all from Northern Michigan University. Thank you very much.